And polar means they are sharing, there's an unequal sharing. There's a little bit of electrical charge difference, okay, not completely the same. I think this is the last one. Last one would be the hydrogen bond. So if you look here, one thing to think about is the hydrogen bond, opposite attract. So these are not actual bonds. Okay, they're very weak bonds. Okay, it's just from a positive and negative attraction. Okay. So again, here's a water molecule, H2, so there's 2H, H2O, and is with a covalent bond. Do you remember if this is polar or non-polar? It is polar because it's not sharing on the side equally. There's a little bit difference, it's a bit weaker. And the hydrogen bond is formed between the positive and the negative one, and it's just a weak bond. This bond holds your DNA together. So now we're going to look into a little bit of chemical reaction. We're going to learn what a reactant is, what a product is, and what a catalyst is. Okay, so if we just look at this, this is the making of salt. Sodium and chloride is sodium chloride. Okay, so the reactant is on the left side of things. Okay, what plus what, and this is the product. The product is the end result. Okay, so this is easy. Catalyst is usually in the middle. Okay, catalyst is either a chemical or heat or temperature that causes the reaction to go faster or slower. Okay. We're talking about energy. To get the matter together, you can break and form bonds. Well, in order for the bonds to break, okay, you need energy to break them. You guys know what a kinetic and potential energy is? Kinetic energy is the actual movement of things. For example, rolling a ball is the kinetic energy, actually rolling it. Potential energy is what is actually is not doing any job yet, but is actually what is the potential energy that it has. For example, I have the ball on top of a hill. What is the potential energy as it rolls down? Okay. Okay. Type of reactions. Okay, this has to do with remember we talked about anabolism and catabolism. Okay, so when you synthesize something, synthesize meaning making things. Okay, you're growing things. For example, here are two sugar molecules. Okay, put them together, it grow to be one molecule. Okay, so this is growing. Okay, this is catabolic reaction. Okay, this is anabolic reaction where it grows. Okay, like anabolic steroid. Okay, decomposition. Decomposition, for example, if you look here, there are two molecules. Oh, your body needs the energy. It breaks it apart. Okay, by adding water. And then it becomes two molecules that the body can use. This is decomposition. It releases energy. Okay. And exchange is just, for example, this molecule. You just change things around. Sodium chloride and water. The sodium becomes together with the chloride, and the hydroxide ion with another hydrogen ion becomes the water molecule. Okay. So 3 types of reaction: synthesize, decomposition, and growth. Factor that affects the rate of chemical reaction. Told you the temperature could affect it. Usually a higher temperature means faster. Okay. And the amount of concentration it has. The more it has and the higher pressure it gives, the higher pressure it be squeezing it, okay? It'll change the reaction time. And the catalyst is something that's added, for example, an enzyme, something that's added that helps with the, instead of the reaction time being this long, the reaction time now is this long, okay? It's much faster. So there are several inorganic compounds that our body is absolutely necessary for life, essential. Okay, so what's the difference between inorganic and organic compound? Organic compound has carbon and hydrogen in it. Okay, one of the inorganic compound that we absolutely need to survive is oxygen. It doesn't have hydrogen or carbon. Okay. Another one is carbon dioxide. Even though our body, when you breathe in oxygen and you let carbon dioxide out. Even though carbon dioxide is toxic to the cells, we need it. Okay. We're going to learn this in AP2, where carbon dioxide is needed to help buffer some of the acid and base reaction. And one of the reasons we breathe is not because our body needs oxygen. One of the reasons we breathe is because our body has too much carbon dioxide buildup. And then the body will start breathing. Just like when a baby comes out, if you hold your breath, it's not because, oh, your body does not have enough oxygen. It's because the body has now too much carbon dioxide. Okay, so carbon dioxide is very important. Inorganic salts, some of them, for example, potassium. Okay, we'll learn about those later. So, but one of the most important ones are oxygen and carbon dioxide. Okay, inorganic compounds. And then water. Okay, water is stabilizes. Water is so important in the body, of course, we know. Stabilizes temperature, absorbs large amount of heat, protects you, cushion. Okay. Water is also called a universal solvent because it can dissolve pretty much everything. Okay, and it helps with transporting. For example, your blood is mostly water, right? One of the things we saw up here that I didn't point out to you, during synthesis and decomposition, if you look here, the hydrogen and the hydroxide ion, this and this will become this and water. And then, so water is taken out, okay? But in this reaction, you put water in there, and it breaks it down to break this down and to form more energy. So here it is. When you take out water, it's dehydrating it. But when you put in a water, it's called hydrolysis. Okay, this dehydration, hydrolysis. Hydrolysis, water, it means water. Lysis means break. So the water will actually come in and break things. Okay. So in ionic bonding, we get something called acid and base and salt. Okay. And let's look through here. What is an acid and what is a base? Okay. Acid, of course, we can think about something sour. Okay. Base is actually usually something salty. Okay. But to actually identify them and categorize them, if you release more hydrogen into a solution, okay, you're an acid. Okay. An acid is usually less than 7 pH. pH is the measurement of acid and base. Let's look down here at this chart. Okay. 7 is neutral. Okay. As the pH drops, so this pH, the number gets lower, the more acidic. Okay. As pH gets stronger in number, it's more base. Now, of course, both of the extreme cases of extreme base and extreme acidic will burn you. Okay. And it's measured in the amount of free energy, free hydrogen that is in the solution. Okay. It's inverse log because as pH goes up, hydrogen is less.